Hello student, in the chapter structure of atom, today we will discuss Bohr atomic model. Yes student, according to this model is based on quantum theory of radiation and classical law of physics. First thing is that this model is based on the quantum theory of radiation and classical law of the physics. Dear student, Bohr models applicable only for the single electron species like hydrogen, helium plus, lithium double plus, sodium 10 plus, uranium 91 plus, etc. Dear student, it is applicable only for this law. This model is only applicable for hydrogen like species, means a species which have the single electron. The Bohr model applicable for single electron species or atoms. Okay, dear students, Bohr model based on the particle nature of electrons. So we see that the quantum theory, Bohr model based on the quantum theory of radiation and classical law of physics, and it is applicable for single electron species, and the models based on the particle nature of electron. Dear student, Bohr model support particle nature of matter. Dear students, electrons have the dual behaviors, wave-like and particle-like behavior. But Bohr support particle nature of electrons. Okay, particle behavior of electrons. Now discuss the important postulates of the Bohr's. Student, the first postulate is electron revolve around the nucleus in a circular path known as orbit. Dear student, an electron revolve in a circular path. The path is known as orbit. Like here, a nucleus, around the nucleus electron revolves in the circular path. This path is known as orbit. Okay student? Dear student, electron can revolve only those orbits in which angular momentum is mvr of electron, integral multiple of h upon 2 pi. Okay, you know that the angular momentum represented by mvr. Here mvr, the angular momentum of electron, here m is the mass of electron, v is the velocity, by which velocity electrons revolve, r is the radius between the nucleus and orbit. So here are mvr, mass, velocity and radius of electron is equal to nh upon 2 pi. Here n is the integer. Which type integer? N is positive integer number, which is 1, 2 or 3. Yes friend, like here the orbit which is present close to the nucleus is the first orbit. For the first orbit, the integer value is 1. Okay, so we say that the integer value is always positive number, that is 1, 2 or 3, 4, 5, 6. Just put here h is Planck constant. Just suppose the integer number is 1, then the angular momentum of electron became h upon 2 pi. When integer number is 2, then angular momentum became 2h upon 2 pi. When integer multiple is 3, then angular momentum of electrons became 3h upon 2 pi, and so on. Okay. Dear student, but always remember that angular momentum of electron cannot be fractional value like 1.5 h upon 2 pi, 0.5 h upon 2 pi. It is not possible. Always remember, n is a positive integer, not a fraction. Okay. Dear student, the next postulate is the orbit in which the electrons can revolve is known as a stationary orbit. Dear student, electrons revolve, you know that the electron revolve around the circular path, around the nucleus in the circular path, that is known as orbit. But this orbit is known as a stationary orbit. Why? We say that a circular path or orbit is stationary. Why? It is because in these orbits energy of electrons is always constant. It is because in these orbits energy of electron is always constant. And these orbits are numbered 1, 2, 3, 4, 5. For first orbit K, second orbit L, third orbit M, fourth orbit N, and fifth orbit O, and so on. The notation are used from the orbit counted first, second, third, fourth, fifth from the nucleus outwards. Like here the nucleus. So outwards nucleus, the first orbit, this is K cell or first orbit, and then second orbit, that is and is for the second orbit integer value is 2, and this is known as L cell. Third orbit, for the third orbit n is equal to 3, the integer value is 3, and this is known as M cell. Now here fourth cell, that is known as N cell, and for the fourth cell integer value is 4, and so on. Okay, these are things very important for you, that if n is equal to 1, then use notation K, and this orbit is known as ground state or ground energy state. Dear student, here n is equal to 2, it's so second orbit, that represented by notation L. Dear student, this is the first excited state. Okay, n is equal to 3 means third orbit. The notation used for this orbit M. This is known as second excited state. N is equal to 4 means fourth orbit. The representation notation M. This is known as third excited state. n is equal to 5 means fifth cell, fifth orbit. Notation O. This is known as fourth excited state, and so on. Okay. Dear student, the emissions or absorption of energy in the form of photon. Dear student, always remember, the energy emitted or absorbed in atoms in the form of, always in the form of photon, means light, radiation, can only occurs, but it is occurs only when electron jump from one stationary state to another. Dear student, according to Rutherford say that according to Rutherford models, when we apply Maxwell concept on the Rutherford, it say that when electrons revolve in the circular path of the atoms, it lose their energy and go closer and closer to the nucleus, and atom collapse. But Bohrs do not accept this concept, this postulate. Bohrs say that the emission of or absorption of energy in the form of photon can only occurs when electron jump only when electron jump from one stationary orbit to another. Dear student, like here electrons of the first orbit, that is n is equal to 1, and this energy of this orbit E1 energy, jump to higher energy, that is E2, and the integer number is 2, n2. When electron jump from lower energy to higher energy, it absorbs energy in the form of photon. You know that the energy of photon is h nu. When electron jump from lower energy to higher energy, it absorbs energy in the form of photon, that is h nu. But when electron jump from higher energy to lower energy state, then it release the energy in the form of photon, that is light. Dear student, the energy difference when electron jump from lower to higher or higher to lower energy, it calculated by using this formula. Delta E, difference of energy, is equal to energy of higher minus energy of lower. Okay, higher energy minus lower energy is the difference of energy. This is also written as En2 minus En1. Okay, dear student, this energy difference is also known as energy of quantum, that is represented by h nu. Okay, so we say that delta E here the h nu or energy of quantum. If in the question asked energy of quantum, energy of photon, then you calculate energy of higher minus energy of lower. Okay, take screenshot. Dear student, the next postulate, energy absorbed when electron jump from inner to outer orbit. Energy absorbed when electron jump from inner orbit to outer orbit, but energy emitted when electron move from outer to inner orbit. Yes, student, always remember, energy absorbed when electron move from inner to outer, but energy released when electron move from outer to inner. Okay, and you always remember that in the formula n2 En2, here n2 is always greater than n1. Okay, n2 is always greater than n1 whenever emission or absorption of the energy will be occurs. Okay, student. Yes, student, this is a very important for you, and it is also important point for you for the calculations related to the Bohr's model of atoms. Dear student, in next lecture we will discuss applications of Bohr model. Please read the NCERT book in which Bohr's models are given. Thank you very much.